last week, actually not last week, this Monday. So I went over basic concepts of linear algebra. If you cannot hear me, you can sit closer. So this basically is one-page summary of what we discussed on Monday. I hope you can understand all these basic items pretty well. It's very important. So first, so these are the three representations of line: high school, middle school, data mining class. Sorry, not high school, college, and the data mining class. And then, so this is the representation of line that we adopted in our class. So basically it is, suppose, right, we have two dimension, x1, x2, and x1, x equal to x1, x2, which means belong to R2. And any line can be represented as W dot x plus B equal to 0. And you should understand the meaning of W, the meaning of B. W basically is a vector that is perpendicular to the line. If you replace this 0 with a positive value, basically the line moving towards in parallel to the direction of W. So which means W basically tells you this is a positive space, this is negative space. Because any point here, it satisfies W for x plus B greater than 0. You follow? Right? And any point below this line must satisfy W for x plus B less than 0. So this is a geometric interpretation of the line, and it's fundamental of support vector machine. And B, right? What is B? B basically tells you the distance of your line to origin. So this is B. Again, right? So this is called W2 norm, which is the Euclidean distance of W to origin. Make sure you understand the meaning, right? This one. Okay? Basically, W is a direction that is perpendicular to a line. B tells you the distance of the line to the origin. And then any point, for example, suppose this point here, right? Any point, for any point, if we want to calculate the distance of the point to the line, you should know the formula. So the distance is W dot x star plus B W to norm. distance is important, you need to write down this formula. Because midterm exam, you need to use this formula to calculate the distance of each point to this line. Because the distance of your point to the line basically tells you how confident you can classify a point. The longer the distance, the more confident. So if the distance is equal to 0, which means equal chance to be true, equal chance to be false. That's all. This is all you need to remember. Enough. Right? Make sure you need to write down everything here. Okay? And then, so this basically what W, E. And then you can convert representation 1 to representation 2 based on this way. You can convert representation 2 to representation 3 based on this way. Okay? And then given a line w dot x plus b equal to 0, you replace 0 with a plus or minus c. C is positive. Basically, you are moving your line towards direction w or reverse direction w. If it's positive c, you are moving the line towards direction w, going up. Now, if for negative c, right, you're moving the line in the direction, reverse direction of w, going down. So which means so this is a line, right? W dot x plus b equals 0, right? So if you say this parallel line that is above this line, suppose this w, this direction w, and then this can be represented as w dot x plus b equal to c, c greater than 0. And equal distance, this line is w dot x plus b equal to minus c. Okay? So that's why this is how to represent parallel line. And then how to represent a point, the distance of a point to the line, which is this formula. To make it consistent, let me use this x0. Any point, x0. Okay? Any question? Very, very important. The reason is because in the following part of the lecture, we will use symbols more and more. Okay? So you need to get used to all the variables, all the symbols. Because suddenly, so far we see the geometric interpolation, but suddenly we go to linear algebra, all symbols, all variables, linear equations, right? So you need to make sure you understand the meaning of all the symbols, right? W, B, distance according to the line, and plus C, minus C, which represent a parallel line. And then, so if this is C, right, then the distance is C W norm. This distance is a C W norm. And then if we normalize, say C equal to 1, then this becomes 1 becomes 1. So this is w dot x plus b equal to minus 1. W dot x plus b equal to 1. So which means the distance between these two lines is 2w norm. If you remember, right, suppose about the machine, right? So we use two parallel lines to define a margin between two classes. And the margin, the size of the margin is 2 over w norm. Okay? So if you do not have questions, make sure, right? So this is a margin. The margin between two lines. +1 equal to +1 minus 1 is 2 over W naught. Okay, so now go to lecture C. Intuition. So this is another example. Suppose we have two classes, red class and black class. So we have two objects, 2 points for red class, 1 point for black class. And we want to find a line that can separate these 2 classes. And in this simple case, we have many lines that we can separate, right? And then start just like decision tree. So, I mean, we have multiple decision trees that work well in your training table. We need to decide what is the best decision tree. And here, we have multiple lines that we can separate 2 classes. We need to decide which line is the best line. And now tell me which is the best one? 1, 2, 3. So basically, you can think about, I mean, basically, the best line is the line that has largest margin. Then you need to figure out, given any line, how to calculate the margin. So margin basically is a white space, okay, maximum white space of a line. White space, which means the space should be clean. There should be no points within the white space. So now I will do a survey. How many will vote for 1? How many will vote for 2? Okay, how many will vote for 3? Half of the students were unable to decide. Right? Again, so you need to get used for any line how you can calculate margin, right? So that's why we need examples. So I prepared a number of examples because half of the students, I mean, cannot clearly identify margin. So that's why I feel, so which means the examples that I prepared are very appropriate. So let us consider one by one, right? How about the line 1? What is the margin of line 1? What's the margin of line 1? 0, right? So keep in mind, right? A separating line should separate 2 classes. And this line does not separate 2 classes. So for midterm exam, right? When you decide a separating line, make sure the line should separate 2 classes. You cannot draw this line as the separating line. So you should at least, right? I mean, between these 2 classes, you can decide this line, this line, this line. That's fine. But this line does not separate 2 classes, and this line does not separate 2 classes. So keep in mind, right? So the first rule, the separating line should be a line separate 2 classes. Otherwise, it must be wrong. Okay? So now let us check line 3. What's the margin line for line 3? So first, right? I mean, any separating line, we use this formula to represent. Start with dot x plus b equals 0. Right? Start with dot x plus b equals 0. Okay? And then the right line is start with dot x plus b equal to 1. So here we define black. Black class is positive class. Red class is negative class. Okay? If you define red class is negative class, then this should be w.x plus b equal to minus 1. Okay? And then another boundary is w.x plus b equal to minus 1. So which means this is the positive space. This is the negative space. Okay? And then, I mean, for all your data sets, these are uniform. But different data sets, W and B are different. Okay? So keep this in mind.
And it's +1 or -1, that depends on the vector. I mean, the direction of the vector, right?
Yeah.
So
which
how are we
means,
deciding this? Which?
so because we define this in positive space.
I mean, that's up to our definition, right?
If we define, so keep in mind, right? So the direction, the W should be either this direction,
Yeah.
or this direction,
Right.
right? And because we define black is positive class, so which means we basically constrain W must go this direction. So if you pick W go that direction, which you define red to be positive. You follow?
Yeah.
Okay. Any other question? So this is the margin for this vertical separating line. Okay. So now let us try another.
So the margin is basically the distance or just the equations? What's the margin in here? Like the distance?
Margin basically is. So this is your separating line, right?
Okay.
So you move the line
Right.
in parallel to both directions, equal distance, until it cannot move further.
Right.
And then the length, the width,
That's
is called margin, which is that's why actually.
Yeah. B.
So this is margin, and it has general form 2/2 norm, W norm. So different data sets have different W, right? So that's why the margin is different. Okay? Any other question? How about this one? What could be the margin? I mean, for a midterm exam, right? So give you a data set, you need to decide what is the best line. So basically, you try multiple lines, multiple candidate lines. So each candidate line, you see what is the margin. Okay? And then you identify a line, the margin is maximized. So this is how you can figure out. So, I mean, I hope you looked at the exam questions that we used in previous 4 years. So I give you some data points. You need to figure out what is the best line for SVM. You think about it, right? So basically, I move this line in parallel to both directions, equal distance, until I cannot move further. Because if I move further, margin is not a margin anymore because it includes some points within. This is not allowed. Okay? So you can imagine what could be the margin like, right? So again, so this line is called W dot x plus b equal to 0. So this is the margin. So by the way, right? I mean, if your line does not touch so for one side of the line margin does not touch any points, which means the line is not the best. Okay? So which means you can find a line, the margin is larger. So that's why that you see we always have points that touch both sides. It's because otherwise this line is not the best. Which means you can find another line, it touch both points, different class on the two sides, and the margin is larger. And again, we use general form. The right boundary is called W dot x plus b equal to 1. The left margin, the left boundary is W dot x plus b equal to minus 1. Okay? So keep in mind, I will remind again, right? Different data sets have different W and b. Okay? For this reason, even we have uniform form because variables have different values for different data sets. And then this is a marginal width. Margin size is 2/W norm. Okay? So now you compare this one with this one. Which one is larger?
Second.
This one larger, right? So for this reason, 2 is the best. Another example. Okay, this is called a separating line returned by SVM. And the points within the boundary are called support vectors. So I'll tell you, why support vectors are important. So you keep this question later. I'll explain. So we have 3 support vectors. Okay? I'll explain why support vectors are important. How about this one? So this is a okay. So again, right? So if you remember, so we tried 3 lines, and we figure out line 2 is the best, right? Because the margin is largest. And now I add 1 point and see if the line will be if the best line will change. I add 1 point here, right? You see? Point here. I add 1 point. My question. Is the separating? Is the best separating line still the same? You can try it. It's still the same. Why? Because you see here, right? So this is the largest margin, and the point is here. The new point we add is here. Okay. So actually, this is called support vectors. Support vectors are the lines, the points that decide your line, decide your margin. So which means, you can remove all other points, only keep your support vectors. You get the same conclusion. Okay? So as long as any points are not within this margin, are outside, you will not affect. This is the best line. The point I just added is here, right? So this will not affect the margin. Okay? So now I add another point. How about this one? Will change? This one? No, right? Because the margin, see here, right? The margin is still margin, right? So which means unless you place some points within this margin, then it becomes a different story, right? So now I move this point to here. I move this point to here. So which means I move a point to this margin, to the inside of the margin. So I move the point, or actually I add 1 point here, right? This point. And if you remember, this is the margin, right? Now I add a point, the point is within the margin. Okay? So now the margin is not a margin anymore, right? Because it has one red point within, which is not allowed. So margin is the white space between 2 classes. We call it white space, right? Must be white space, no points within. So for this reason, because we add a point within the margin, then the best separating line change. So tell me which one is the best one?
3. 1.
1?
3.
No, 3.
1 cannot, because 1 does not separate 2 classes. Right? You see here? So, below is red, above 2 red, 2 black, right? Or below is one red, one black. So this line does not separate 2 classes. Right? So for this reason, 1 can never be the separating line. At least the line should separate 2 classes completely. Okay? So which means the line should include half space that includes all points of one class, another half space includes all the points of a different class. Cannot be mixture, right? It's a mixture, right? You see here, below, mixture, above, mixture. So this line is not visible. So now the only 2 options are line 2, line 3. So now my question, right? Can you guess what is the margin for line 2?
Pretty less.
Very small.
Pretty less.
So basically, you need to move this line, this direction, equal size,
Yeah.
until it touches this point, right? So the margin like this. This is the margin size. So this one, right? Again, right? So this is double dot x plus b equals 0, right? This is general form. And then the margin, this is the margin, right? And then the margin becomes much smaller, right? And then the upper boundary is called double dot x plus b equal to 1. The below boundary is double dot x plus b equal to minus 1. And then, how about 3? 3 is still the same, right? This is the margin. The line is double dot x plus b equal to 0. The right boundary is double dot x plus b equal to 1. Left boundary is double dot x plus b equal to minus 1. And then this is a marginal width 2 over 2 norm. Okay? So this is a separating line, and we have 3 support vectors. Okay? 2 red, 1 black. How about this one? Which one is better? So first, right, all the 3 lines completely separate 2 classes, right? That's good. So which means they're all separating lines. But which line has largest margin? How about 1? This is the margin size, right? And then how about this one? This is marginal width, right? Marginal size. How about this one? Could be here, right? So which means 2, right? 2 likely has largest margin. So I will show the margin one by one. So let me first show the margin for line 1. This is margin. How about line 3? This is margin, right? Line 4. Which one is larger? Which one is largest? Clearly this one, right? Okay? So this is ideal, right? So for a middle exam, you just try multiple lines, right? You find multiple lines that are separate 2 classes, and then see which line is the best. So make sure, right? You need to find a line. The boundary of the margin should include 3 points.
It's like at least 3 points.
It can be 2, but I will prepare questions that you always find 3. Make your life easy. 2, yeah, I mean 2. I mean it is possible 2 are enough. So another example. So again, here we have 3 support vectors, right? 1, 2, 3. So now another example. Tell me which one is the best. So you compare with this one. So basically, I swap this point, from red class to be black class. So now we have 2 black points, 1 red point. Right? See here? We have 2 black points, 1 red point. Previous example, we have 2 red points. Previous example, this is red, right? Now I have 2 black. Tell me which one is the best? 2, right? Actually, I mean, even we say I found it difficult to calculate margin, but just based on your, just based on your intuition. I mean, you can figure out actually 2 is too likely to be the best. So this is I would say the magic of support vector machine, right? Even it has mathematical formulation, heavy mathematical evaluation, but it matches your intuition. Okay? The basic idea is, right? The basic idea, I mean, is how can we define the white space between 2 classes, right? How can we mathematically define the white space between 2 classes? So support vector machine basically gives you a way to use +1, -1, 2 parallel lines to define a marginal space. So let me show one by one. So let me first show what is margin for 1. So this is 3. This is margin for 3. You see here? So it touches the black point, right? But here, See? So the upper boundary does not touch any point. So which means 100% this is not the best one. At least you should touch 2. I mean, make your life simple, touch 3. You make sure you find a line. Find a line that separate 2 classes. Rule 1. Rule 2. The boundary of your margin should touch 3 points. Rule 2. So as long as you can satisfy rule 1, rule 2 in your midterm exam, you should be 100% confident. You find the best, the correct, the correct solution. Make sure, right? Rule 1, the line should separate 2 classes, right? So be very, very important. You cannot use this line, right? No, because you see, you do not separate 2 classes. Because below the line, 2 points mixture different class. So you can see you can pick this line, or you can pick this line, or you can pick this line, but you cannot do this line, right? Because this line does not separate 2 classes. This one, no, because it does not separate 2 classes. Rule 1, rule 2, right? You need to write down for midterm exam. It's very important. So now I try another example. So this is why this is a separating line returned by SVM, and here we have 3 support vectors. So by the way, right? So this is 2-dimensional space. So we only have 3 support vectors. In the high-dimensional space, it could be many, many more. So this is another example. You see it's the same. Yeah, just show the results, right? I think here, so this is 1. So in this example, so this line does not touch any point for the upper boundary, right? Because it cannot extend anymore because this one already constrained, it cannot enlarge. And then this boundary does not touch any red point. So for this reason, this line is not the best line. And this one, it looks like it touched 2 points, right? But unfortunately, this upper boundary still does not touch any point. So which means it's not the best one. So in order to touch, you need to move this up a little bit. Okay? Make sure this boundary will touch this point. And then this is the best separating line because you can calculate the margin is largest. Again, right? So this is an example where only two support vectors. But again, I mean, don't worry about 2. I'll prepare questions. You will find 3. Okay? Because in practice, you do not need to manually find the line. In practice, you need to just apply optimization. It's a tool, black box tool. It automatically finds the best line for you. Okay? In class access, how about this one? Give you 3 minutes, figure out what could be the best separating line. Please practice. Think about this actually, this is like your midterm exam, right? So this has there's a question related to this. There's a problem related to this that has a 40 points over 100. So please tell me what is the best separating line? So basically, let me show an example, right? Suppose this is margin, right? Okay, so so this margin, so in order to enlarge, I can enlarge here, and I can copy the right line. So So this is separating line. So is this the best line?
No, it touches 2 points.
So let me, so if we rotate, make sure each wall touch 2 points. Then, great.
Yeah.
So we have a margin that touch 3 points, right? And then the separating line is a line in the middle. Right? So this is the best separating line. It includes 3 support vectors. Support vector 1, support vector 2, support vector 3, right? Because I mean, if you want to rotate, for example, cannot, right? Because this point is included. How about this one? We rotate. This point is included, right? Okay? So you can only do this way, in parallel. So this is how you can figure out the solution. Okay, so now we figure out, okay, this is the best line, so how to calculate W and B. So I will show the the steps one by one again, and then next one I will ask you to calculate W and B by yourself. So we have 3 support vectors, right? So let's see how about this support vector. 1, 2, 3, 4, 5. 1, 2, right? So support vector 1 is 1, 2, 3, 4, 5, 5, 2. Support vector 2 is